Okay, now we'll be looking at limits to infinity. So as the denominator gets larger, the answer gets closer to 0 when you're looking at limits to infinity. So an example would be this graph, whereas you have the limit as x approaches infinity of 1 over x, that is equal to 0. And it's the same for the limit as x approaches negative infinity. So this would be going up to this would be going to infinity, this would be x approaching infinity, and this line would be x approaching negative infinity, and they are both 0. So as f of x gets smaller, x is approaching infinity, and the limit is becoming 0. So this shows the limit as x approaches infinity of 1 over x squared equaling 0. The higher the exponent in the denominator, the faster the function gets to 0. And these are examples to show you that if your final answer is infinity over a number, your answer will still be infinity because infinity is so much higher than that number. It's the same thing as a number multiplied by infinity, the answer will still be infinity. If you end with infinity over infinity, the answer is indeterminate. So these are examples when you're finding the limit of as x approaches infinity with the degree of the numerator being greater than the degree of the denominator. This example shows that the limit when the limit equals the degree of shows that when the limit of the degree of the denominator equaling the limit of the degree of the numerator, then you will find your answer by finding the leading coefficient of the numerator divided by the leading coefficient of the denominator. And this example shows the degree of the numerator being less than the degree of the denominator. So as the limit of x approaches infinity, when the degree of the numerator is lower than the degree of the denominator, then the limit will be equal to 0. And for our last example, when the degree of the numerator is greater than the degree of the denominator, then the limit will be infinity. So an example will be the limit as x approaches infinity of 2x squared plus 5x plus 5 all over 3x squared minus 2. So because of our quotient rule, we will need to write the limit as x approaches infinity of 2x squared plus 5x plus 5. You will divide this entire polynomial by x squared because that is the degree of the numerator, and you will divide this by the limit as x approaches infinity of the denominator's polynomial 3x squared minus 2 all divided by x squared. And so you will end up with the limit as x approaches infinity. You will distribute this x squared by dividing each of the terms by it. So that will be 2x squared over x squared plus 5x over x squared plus 5 over x squared divided by 3x squared over x squared minus 2 over x squared. And this will be equal to the x squared and the x squared here will cancel out, so this will be 2. This x will cancel out with the x squared, so it will be plus 5 over x plus 5 over x squared, since nothing cancels out in this last term, divided by 3, since x squared divided by x squared cancels out and leaves you with 3, minus 2 over x squared. So you will have the limit as x approaches infinity of 2 plus the limit as x approaches infinity of 5 over x plus the limit as x approaches infinity of 5 over x squared, all divided by the limit as x approaches infinity of 3 minus the limit as x approaches infinity of 2 over x squared. And so you will make this equal to the limit as x approaches infinity of 2 plus the limit as x approaches infinity, well, 5 times the limit as x approaches infinity of 1 over x using the constant multiple rule plus 5 times the limit as x approaches infinity of 1 over x squared, also using the constant multiple rule, divided by the limit as x approaches infinity of 3 minus 2 times the limit as x approaches infinity of 1 over x squared. And so as I showed you earlier, 1 over x and 1 over x squared for the limit as x approaches infinity will be equal to 0. So when you plug in 0 for those terms, you will end up with 2 plus 5 times 0 plus 5 times 0, which equals 3 minus 2 times, divided by 3 minus 2 times 0, which gives you 2 over 3 as your answer. And using the shortcut for the leading coefficient, since the degree of the numerator is equal to the degree of the denominator, your answer should be 2 over 3, which is what we got in our end result, 2 over 3.